All right, so I'm here and we're going to do an application problem with 3 variable systems, okay? So we got a bit of a situation here. We got a marketing department, okay? This marketing department of this company has a budget of $30,000 for advertising. That seems kind of important. I'm going to go ahead and circle that. So they got 30 grand for advertising, okay? And a TV ad costs $1,000. A TV ad costs $1,000. A radio ad costs $200, and a newspaper ad costs $500, okay? Now the department wants to run 60 ads per month, and have as many radio ads as TV and newspaper ads combined. As many radio ads as TV and newspaper ads combined. Okay, combined. That's a pretty big word. That's a good word. How many of each type of the ad should the department run each month? Now I went ahead and underlined that each type a couple times because that's actually a very important piece of information. A lot of times when people are doing these particular word problems, they really struggle on figuring out what our variables are. And what's kind of interesting is that the question itself is generally going to tell you what the variables are, or at least what they should be, okay? In this case, we're saying how many of each type of ad should the department run. That's what we're trying to find. Each type. How many of each type of ad, okay? So that's exactly what our variables are going to be. I'm going to say X is the number of TV ads. I'm going to say Y is the number of radio ads. I'm going to say Z is the number of newspaper ads. So there's our 3 variables. How many of each type should we run? Well, X is going to be how many TV ads we should run, Y is going to be how many radio ads we should run, and Z is going to be how many newspaper ads we should run, okay? And how are we going to get there? Well, they got a budget of $30,000, okay? They got a budget of $30,000. How are they going to spend that $30,000? Well, a newspaper ad costs $500 each, okay? So a newspaper ad is going to cost $500 each. A radio ad is going to cost $200 each. And a TV ad is going to cost $1,000 each, okay? A TV ad is going to cost $1,000 each. So 1,000X is going to tell us how much we're spending on TV ads. 200Y is going to tell us how much we're spending on radio ads. 500Z is going to tell me how much we're spending on newspaper ads. Add them all together, that has to be our budget of $3 grand, all right? They also want to run 60 ads per month. Well, if they take the number of TV ads X, the number of radio ads Y, and the number of newspaper ads Z, and add them all together, that's going to be our 60 ads a month, okay? So we have these 2 equations. Now we get to, they want to have as many radio ads as TV and newspaper ads combined, okay? They want as many radio ads as TV and newspaper ads combined. If there's 10 TV ads and 5 newspaper ads, there's going to be 15 radio ads, okay? So the number of radio ads is going to be equal to the number of TV ads and newspaper ads combined, okay? So these are the equations, okay? Y equals X plus Z, X plus Y plus Z is equal to 60, and 1,000X plus 200Y plus 500Z is equal to 30,000, okay? So now we can go ahead and solve this particular system, and in this case, I'm actually not going to use elimination. In this case, we have a variable already solved for. Y is already solved for, okay? Y is X plus Z. So we can actually kind of quickly use substitution. I can take this Y is equal to X plus Z and substitute it in for Y in this equation, and also substitute it in for Y in this equation. That's exactly what I'm going to go ahead and do. So we're going to have 1,000X plus 200Y. Well, Y is X plus Z plus 500Z is equal to 30,000. Okay, now we can go ahead and simplify this. This is going to be 1,000X plus, I'm going to distribute the 200 plus 200X plus 200Z plus 500Z is equal to 30,000. Okay, and once I clean this up a little bit, I can combine these. These are like terms. That's going to become 1,200X. These are like terms. That's going to become 700Z is equal to 30,000. 30,000. Okay, so that's one of my kind of new equations. I'm going to go ahead and get that kind of in its own color because that's going to be very, very important. Okay, and now I can do the same thing and substitute in y, which is x plus z, into my second equation here. So that's going to be x plus y, which is x plus z plus z is equal to 60. So I took x plus z and substituted in for y, and that's going to get me 2x plus 2z is equal to 60. Okay, now from here there's two ways we can go. We have two new equations in two variables, and this is kind of its own little mini system, okay? And we can solve this using any of those Algebra 1 concepts that we already know. I can use elimination. I can go ahead and use another round of elimination to eliminate either the x's or z's and solve for the remaining variable. But I'm actually going to keep going with substitution. I'm going to go ahead and solve for x in this case. I'm going to go and solve for x in this case. So I'm going to keep going. I'm going to subtract each side by 2z. I'm going to subtract each side by 2z to get 2x is equal to 16 minus 2z. And now I'm going to go ahead and divide each side by 2 to end up getting x is equal to 30 minus z. And now I have x is equal to 30 minus z, and I have this equation over here that's in terms of x and z. Well, what I can do is I can take this 30 minus z for x and substitute it right in, and now I can go ahead and solve for z. So that's exactly what I'm going to go ahead and do. So I got 1200 x. Well, I just found x to be 30 minus z plus 700z is equal to 30,000. And I can go ahead and keep solving. I can go ahead and distribute this here. I'm going to end up getting 36,000 minus 1200z plus 700z is equal to 30,000. And now I can go ahead and simplify this a little bit. I got some like terms I can combine. So I'm going to have 36,000 minus 500z combined like terms is equal to 30,000. Okay, I'm going to go ahead and scroll down just a little bit. And now I can keep going. Now I can go ahead and subtract 36,000 from each side. And now I'm almost there. Finally almost there. So I got negative 500z is equal to negative 6,000. Divide each side by negative 500, and we get z is equal to 12. We finally got a variable, okay? We know z is equal to 12, and remember z represented the number of newspaper ads. So I know that the number of newspaper ads is 12. I have that now. And now what I can go ahead and do is I can find out how many TV ads there are, okay? Because what I can do is I can take this 12 for z and substitute it in for z right here and solve for x, and that's what we're going to go ahead and do. So x was equal to 30 minus z. Well, I now know z is 12, which tells me that x is 18. So now I'm getting somewhere. Now I know that the number of TV ads is 18 and the number of newspaper ads in a month is 12. And now all I need to know is how many radio ads there are. Well, remember, there's one equation we haven't substituted into just yet, and that's this one right here. So now what I can go ahead and do is I can take this 12, substitute it in for z right here, take this 18, substitute it in for x right here, and solve for y. So y is going to be equal to x, which is 18, plus z, which is 12, and that gets me 30. All right, so now we have our final answer, finally. Okay, so now we can go ahead and definitively say that there are 18 TV ads, there are 30 radio ads, and there are 12 newspaper ads. Okay, so that is our final answer, and that's a way that we can use 3 variable systems to solve a particular situation and to help us figure out something from a particular situation. Okay, I'm going to go ahead and do maybe one more video with a different type of word problem, but this is how we do 3 variable systems. I'll go ahead and do that other video. Make sure that you check it out after this one.